Okay, welcome back, everybody. This is the podcast series called Minding Emotions, and it's where a philosopher and a psychologist talk about the nature of the emotions. My name is Stephen Asma. I'm a professor of philosophy at Columbia College Chicago and a member of the research group in Mind, Science, and Culture. And my friend is...
Rami Gabriel. I'm an associate professor of psychology at Columbia College Chicago and also a member of the research group in Mind, Science, and Culture.
Great. And just like our other episodes, we've talked, I think, this is our fourth one, right? So we've had three conversations before this. If you want to listen to it or watch the podcast, be great for you to go back and get those other episodes under your belt, but you don't need to. This is also a standalone conversation about the emotions. And we're going to start, as we've done in the past, with a short puppet show, because puppets are intrinsically fun, and if you're listening along, you'll get a lot of good content here too. So we're going to look at the nature of the triune brain and these emotional systems, and then when we're done with that, it's a few minutes long, then we'll have a sort of critique and discussion afterwards. So without further ado, here come some puppets.
The research group in Mind, Science, and Culture presents The Evolution of Emotion. Part 4. Are emotions in the brain?
In the last century, there's been a revolution in our study of the brain. It's sort of the neuroscience revolution. We have figured out how interwoven emotional processes are with motor, sensory, motivational, and cognitive processes. Neuroscience has revealed how the range of emotional processes is paralleled in the evolved architecture of the brain itself. Paul MacLean's 1949 triune brain model is a helpful way to conceptualize the evolution of survival functions that enlist emotions in purposeful units that connect motivation and behavior appropriately. The triune brain model begins with the earliest version of the brain, the reptilian brain. This is the brainstem, the medulla, the pons. What happens in this area is a mediation of basic instinctual action survival plans for primitive emotional processes like curiosity, thirst, hunger, aggression, and sexuality. Atop the reptilian brain, which is shared by any animal that has a brain, is the limbic system. And we know the limbic system adds behavioral and psychological resolution to these earlier emotions while adding subjective feelings and emotional responses to world events. So we have an interaction here between these innate motivational value systems from the brainstem, the reptilian brain, and social emotions like grief, for example, or play behaviors in children, or care, maternal instincts in mothers. The newest part of the brain to have evolved is the neocortex. We know that the neocortex is a location for higher cognitive functions like reason and logic, and language and executive decisions. But we also know that these can be colored by the emotions. One way to look at the development between these parts is to think of earlier emotional sections as affect, and later neocortical and limbic emotional circuits as emotion, because they're more propositional, you can talk about them with language, and they're more cultural and less automatic. The true genius of this research in the last 50 years is Dr. Jaak Panksepp, who is most well known for his rat tickling experiments. He has convincingly suggested that social mammals possess 7 emotional units housed in the reptilian and limbic systems that connect perception with motivation and behavior appropriately. The first one, the most primitive one, is the drive to explore. He calls this seeking. There's also lust and care, play, rage, fear, panic. Panksepp's work shows these circuits have neuroanatomical and neurochemical foundations. the survival behaviors that they mediate can be induced by putting animals in the appropriate life-challenging or stimulating situations. They can even be induced by artificially prodding the brain. When you activate these 7 emotional circuits, you get the same behaviors across mammals, the same hormonal changes, the same modulation of arousal levels, and the same turning on or off of specific motor routines. What's interesting about humans, over and above all this, is that we have connections between these low-level automatic adaptive behaviors and high-level neocortex behaviors. For example, our automatic behaviors like hunger can be modulated by our cognition, what we know, and our sort of cultural repertoire. On the other hand, we can have very abstract, high-level emotions like angst and cosmic fear, and sorts of philosophical emotions. That's the range of emotions we have, but they're all built upon and through this triune brain model.
Okay, welcome back. And now we're going to discuss some of the features that came up in the puppet show, but also you and I have just read this very interesting work by a psychologist named Luiz Pessoa. Do you think I'm pronouncing that right? And he's currently at University of Maryland. And he's written a very interesting book and a great article in the Behavioral and Brain Sciences, the BBS, called The Cognitive Emotional Brain. And it's a pretty dense argument, but I thought it would be good, and we agreed that this would be a great way to sort of show what some of the criticisms are about the triune brain model. And I think Pessoa, like many other writers, thinks he's got a great revolution on his hands, and therefore, the old ways are completely moribund. I tend to think that what he's doing is giving us a more nuanced improvement on some of these older ways of thinking about the brain systems. But maybe we could start out with just getting a sense. I'll ask you to start, what about this piece struck you, and how do you see it as a kind of critique or amendment to this, what he calls the dual processing brain?
Yeah, I'm excited about this work. I've been doing stuff with cognition and emotion for many years, and to read someone who's saying, well, this view that there's a cortex and then there's a subcortex underneath, and that they're separate things, that cognition and emotion are somehow separate, maybe in processing or even in the way we feel it, experience it, that does not reflect how intrinsically tied in they are in the brain. And his argument is that, well, there's these areas that are sort of hubs, like the amygdala he talks about, medial prefrontal cortex, lateral prefrontal cortex. He's saying we can't talk about them separately anymore because we've done so much neuroimaging and there's so much work out there saying that actually they have to be working together. And the real argument here is he's saying let's take one example of emotions, namely motivation. What we've been talking about in this podcast and in our book is that motivation and salience are elements of the seeking system. And that those things energize the creature, and then they make these neuromodulatory changes in the brain. He is saying, in response to that, he's saying, well, actually, motivation and emotion have to work through particular, what we've generally called cognitive processes. He points out, for example, attentional filtering, changes of working memory, changes of inhibition, selective attention. He's saying, well, fine, emotions are important, but this is, in fact, how they are making the changes. And I think that's the greatest challenge for a triune brain model, is this idea that they're not separate. In fact, it's all being mixed in, and it's, in fact, he's using cognitive language. He's using the language of cognitive neuroscience to say, well, yeah, you have some emotional stuff, but this is how it really is done. So I think that's the major challenge. Is that it's really a strong way of cognitive neuroscience, cognitive science, to take in all the issues that were resolved by a triune brain or a system 1, system 2 model.
Yeah, good. I agree. He lumps together a bunch of stuff that I think probably should be seen as a general paradigm, and that is that and we've talked about it in this podcast too, that there's a kind of dorsal and ventral pathway in the brain, or like you said, system 1, system 2, hot cognition, cold cognition. I think this has been a very helpful model because it explains the way in which these systems can sometimes be in coordination with each other, but sometimes be antagonistic to each other or suppress each other. And he thinks, well, it's time to move beyond that model because the way in which these brain areas are interwoven is, like you said, so complex that it's not layers so much as these networks. And one of the ways he does it is he says, look, the amygdala is really important in emotional processing, but look at how connected it is to all these parts of the cortex, or to the prefrontal cortex. So it's in constant communication with these parts of the brain that we thought of as being, much more cognitive. Yeah. And then he does it the other way around. He says, look at how he runs some patients through some interesting fMRI tests where he gets them emotionally charged, and he's looking at their brain, and he's like, there's a lot of prefrontal activity here during, I think one of the experiments, I don't know if I got this right, but he has like a box around their foot, and he puts a tarantula in this box, and somehow, and he thinks it's all pre-recorded, so the person really isn't not in any danger or anything, but he's looking at when, like you said, there are other systems that are cognitive that are reading the proximity of the spider to the foot or whether it's a real threat. And so he says there's a lot of prefrontal activity during all kinds of emotional stuff too. So I think he's kind of overplaying, for the sake of criticism, the problems of thinking of the brain as triune, because I don't think anybody from MacLean up to, Panksepp thinks that these layers, of the limbic area and the cortex are unconnected with each other. Of course, they're incredibly interpenetrated with synaptic connections and these kind of loops. But I do think he's right in saying it's time to get over this sort of purely structural approach and think more about emergent systems.
Yeah, and he says it towards the end, talking about maybe they're not layers, but they're embedded. That motivational processes are embedded in cognitive processes, and that has to be true. And definitely, we're cognitive linguistic creatures now. Humans are. Now, the interesting work is with animals. How are those things embedded when you don't have linguistic and some of the rational structures? They have inhibition, but I think you were telling me that they finally ran a marshmallow test on a chimp. You were telling me once?
Oh, I might have, but I don't remember now.
I think the non-human animals is really is really what the crux of these of asking these questions.
I think this is a slight downfall of his view, I think, because he's looking at the human brain, where you're going to find the cognition and the emotion much more wedded together because of the things you're describing: language, culture, learning, logic. Animals have rudimentary versions of these things, but I think that in a way the advantage of the triune brain model, or something like it, is that it helps us understand what could be homologous, what's in common with other animals, and what's unique and more late appearing in terms of evolution.
Yeah, but there's an interesting discussion too he has towards the end of it about what does a vertebrate brain, what's a normal vertebrate brain look like, and he argues that they have all three layers already from the most primitive vertebrate brain, which is interesting too. There's two tracks he's doing. He's doing all the neuroscience stuff for the neuroscientists. Then he's getting into the debate about how is emotion embedded in related to cognition. And I guess one critique I would have is that cognitive neuroscience has its own issues. It has its own limitations. And this is one of the sort of meta psychological issues, which is that you have a lot of neuroscientists using behavioral methodology, behaviorism. Then you have these cognitive scientists and social psychologists using this whole other repertoire of what they call a cognitive ontology, saying you have thinking, you have inhibition, you have they're kind of naming these processes. And you have behaviorists using the law of affect, like you do it if it's conditioning language. Mm-hmm. And I think those are still butting heads against each other. And this paper, and there's many people behind this paper. This is not just Pessoa, but he's of course articulating it very well. Trying to usurp, I think, or to use these cognitive neuroscience methods on other things. And I think that's what I think the majority of the field of affective neuroscience or professional affective neuroscience is doing this. It's using the language that we already have on new processes, namely things that generally we used to think, in the 80s, he talks about a little bit, but Zionk.
Oh, yeah.
Or Zionk, I'm not sure if I'm saying it right. But there's all that stuff was like, okay, we have liking and we have emotions and they're kind of underneath and they're subcortical and we don't know exactly what's going on. And we had all this interesting work about blind sight, the two pathways. There's prosopagnosic work that I've done.
Yeah, mention real quick just what that is in case people aren't aware of it. It could be helpful here.
Yeah, in the 80s there was this big rush of people seeing, sometimes it looks like certain individuals cannot, for example, recognize faces. So prosopagnosic patients cannot recognize faces. But they seem to have some sort of accurate reactions to these unrecognized faces. And the famous work is Bauer 84 and 85, and subsequently Biederman and some other people, and then I did some work in my dissertation on this. We found that they actually, although the prosopagnosists cannot consciously process or explicitly declare their understanding of a particular face, that there are other ways of measuring that they actually are seeing and understanding. All of this work set up what happened later, which is this famous Kahneman book and several other theorists saying that maybe there's just two systems. There's one that's underneath and less conscious, less explicit, and there's one that's over and it's conscious and explicit. And that's been the paradigm for many years. And that's what this book is, I think, going after. Mm-hmm. The thing that was exciting about that two-pathway thing to me is that it left some room for other ontologies, really. That, for example, I think the interesting thing is talking about what the neuroscientists are interested in, which is neuromodulatory things. So neurotransmitters are changing. Acetylcholine, dopamine they talk about in this paper. Those things are being varied depending upon these global influences of motivation and emotion. So when we start talking about global things, about volumetric changes in the brain, those things don't have a good language within the cognitive framework, but they have a better language within the neuroscientific and behaviorist framework.
Oh, that's a very interesting way to think about it. I hadn't picked up on that because, that's your field. But I was tracking it from a different perspective because one of the things I really like about Pessoa, the argument is, he says, if you look at the amygdala, he says it's not just, he says it's sort of it's doing both these dual pathway functions in the sense, he says it helps you identify what is it. Something's coming at you and you identify it as a big dog or something. So it has this kind of, what we've called before, a kind of indicative structure, but it also is always involved in what he says is what's to be done. Like you see the dog coming at you, what's to be done is part of the role of the amygdala because my understanding is it's so fused, basically sending signals down towards the brainstem, like move, get out of the way.
Right.
or whatever. You don't just sort of observe the world like a disinterested spectator. You're always engaged in solving some problem, like surviving.
But now that's what the direct perception and the enactivists have been pushing, and that's something he doesn't mention at all.
Right.
Interestingly.
Yeah, that's a good point. Like, we've been looking at this problem from a couple of other different perspectives, like you said, in activism, the idea that the environment is already coded with certain affordances that are going to push or pull us in a certain way. We've talked before in our own book, we've been influenced by Ruth Millikan, and she has a sort of biosemantic view which says, well, there's a way in which the world presents itself to us that it's already both indicative, like that's an animal of a certain kind, but also, she says, imperative, which is what's to be done about it. It's the same sort of issue, but you're right, from a different kind of language. But I do like that about his work, because he says that's what's missing is, he says, there's a line, he says, I'm sure I'm going to get it wrong, but he says there's never just pure cognition. There's only affective cognition. Because, and then his way of getting emotion and motivation into cognition is via perception, I think. It's one of the things he says, like...
Yeah, these perceptual, basically attentional processes.
Yeah, attentional processes.
And there's all this very great work that they're doing.
Yeah.
Saying, look, it turns up attention here, it turns down attention here. It has real effects on what we used to think of as these cognitive processes, namely attention. And I think that's he's bringing forward a real issue. Like I mean, things have been happening in cognitive neuroscience that are exciting. And this is some of the stuff. I mean, the question is really, are we at a time when the cognitive neurosciences are taking a step forward, and that all this neuroscience stuff is starting to be interpreted in a way that makes us want to change other models, or is this another land grab?
Oh, interesting.
Because all this stuff, his main thing is this: you have capacity sharing. The idea is that you only have so much, blood, oxygen, only so much energy, and it has to be shared among these different resources. This is a dual competition model he talks about. Yeah. That you have these emotional and these cognitive things, and they're kind of sharing resources. But this sharing resources thing is resources is a type of information processing language. I'll also say it's also part of this capitalist language.
Oh, interesting.
Of how we interpret the mind within
competition.
Within this competition framework, this cultural framework. Maybe it's not relevant. I don't know. Some historian of philosophy might say it's relevant in the future. But these are paradigms that he's bringing, and these are very tried and true cognitive paradigms. Resource sharing. I don't know. What do you think of it, seeing it from a philosophical point of view?
Well, one thing I like about this idea of dual competition between the emotions and things like attention and working memory and motivation is that this seems like much more accurate when compared with just a massive modularity view of the mind, which is you flick the switch on this module and it simply runs, And at least what he's suggesting here is something where you can't just take infinite blood flow. The brain, the human being, the animal is a finite resource, and you need calories, and it is a system that is biological, which means that the amygdala, the hypothalamus, the hippocampus, these things are not only interrelated with each other in terms of blood flow and sort of just electrical activity, but they're adapted to each other. They didn't just adapt to solve a problem out in the environment, like you've got the Swiss Army knife in your head that just does this one thing. No, each of these capacities co-evolved with each other. So just like other organs in the body, I like this idea that there are systems and that there's biological finite resources. But I do agree with you. He is using a version of this that looks more like traditional cognitive science language, and it's almost like they're thinking of it as digital processors. Like once you've got enough energy from this one, the digital processing stops here or something. Whereas I think the direction of influence, if there's going to be a land grab, it should be in the opposite direction. It should be affective neuroscience, better informing cognitive science. But I think for political reasons, cognitive science has been much more better funded. It's been more dominant. So I worry. I have the same worry that you have, which is now cognitive science is going to go into the emotional realm, but they haven't given up on the computational metaphors of digital systems, so they're never going to get the sort of wet biology of the affective neuroscience view, at least the traditional view that comes out of people like Panksepp and Damasio and so forth.
Right, and there is this other paradigm about energetics, about trying to take this dynamic energy flow, computational language, resource language, and put it into the brain sciences. And I can't remember the name of the person who does that, but there is that kind of work out there too, and that might be another supplement. I mean, I think one of the things we're pointing out here is that this kind of work is great, but it needs to be supplemented by the enactivist idea and the direct perception of Gibson that's already out there. The neuroevolutionary stuff we haven't talked about much, but it has to have an evolutionary basis.
Yeah, one of the things that I think is, we talked about Damasio before in here, and one of the things Damasio argued was, now he's got a new book out that's brand new, and I'm not sure whether he's adjusted his view on this, because he's always sort of learning from the research, and I remember he changed his view of where the self or self-consciousness might be located. He put it back way back in the brainstem, and changed his mind in terms of his earlier views. But he said, well, what's happening is when you experience the world, something like the amygdala, and together with the prefrontal cortex, is marking your
orbital
experience.
Frontal cortex.
Yeah, the orbital frontal cortex. So you see threats, and the memory codes them with a bodily marker, like of avoidance. You see things that are attractive to you or taste good or look good, and you feel a kind of affective tilt to approach, So Damasio is talking a lot about how all cognition is already loaded with these somatic markers. And what I liked about this Pessoa argument is near the end, I wrote it down because I knew I would never remember it, but he gives he's trying to speak to the same phenomenon, which is how is it that concepts, memories, ideas, how is it that they have affective content? And he says, he gives 5, let me see, 1, 2, 3, 4, he gives 5 examples of how vision could be getting some affective content built into the perception. And I'm not going to go through this in detail, but it might be fun to just mention. He says one is the orbital frontal connection you were just talking about, which sort of influences, he says, anterior flows to the ventral visual stream. He says lateral frontal cortex and parietal cortex also creates these priority maps, which I thought was a cool idea.
Yeah.
And ties in with what we already know, I guess, about parietal cortex. He says 3, the basal forebrain influences visual processing through release of acetylcholine, which I didn't follow this very well, but I'll put them all out there and then we can see what you want to talk about. The 4th one is something he seems to think is very important, which is the pulvinar complex of the thalamus, which he thinks amplifies responses to stimuli during challenging sensory conditions. And then lastly, he says that the path from amygdala in the thalamus, which is going, up and down, basically, like towards the front and towards the back. And I love this about the argument, because it's like, it's one thing to say the world is painted with affect, but here he's trying to say, like, what systems in the brain are actually doing the painting,
Yeah, I'm glad you pointed out that to me is the most exciting part about the paper is how do you cash out this notion of somatic marker? How do you cash out this notion of priority maps or salience maps? There's kind of a couple of ways of trying to do it, like what makes something salient And if something is salient, then what difference, what's the change that happens? We've been talking and writing about that you have these energizing things coming up from the lower parts of the brain, including seeking and including these basic instincts, and that they are determining what's important in terms of the larger concept of homeostasis. And Damasio and Panksepp, and many people talk about this. Now, it might be that this is the work that's cashing it out. And that's what's exciting, that maybe yes, that's what's coming up, but how is it then how is it finishing up on the top? This might be it.
Right. That's why I feel like we need some nuts and bolts, as it were. And this work by Pessoa and others of this movement seem to be giving us the nuts and bolts. And it's not that I think this upsets what's been done. For example, I think this might be exactly how the somatic marker works, because when Damasio was writing about it, he was like, I don't know really exactly how this works. Maybe it's somehow the prefrontal cortex. And then we've talked about this researcher before, Cecilia Hayes, and she's coming out of a different tradition, but she talks about, well, how do we match up these these associations such that when we get it into, through developmental phases, we already have the world coded with things that we want to approach and things that we want to avoid. And her word for this is, her phrase for this is matching vertical associations.
Yeah.
So you touch something like the cup, but as you're grabbing it, you're also seeing it. And as a baby and as a child, you're wiring together the motor and the visual sensory system into some kind of mirror neuron unit. Now, that's also it's great because it's explanatory, but it's a little vague on the nuts and bolts again. Whereas I think maybe this work by Pessoa could actually be delivering on this more conceptual work by people like Cecilia Hayes and Damasio.
Yeah, and I think that the way he takes it in, he calls that cognitive schemes. Those associations you're talking about. That there's another interesting one of the comments. There's comments on this paper. It's a BBS article, and one of the comments says, "Well, what is motivation?" I think this is the Pasquale Leone from University of Toronto comment saying, well, motivation must get into this whole process by conatus, which is what we've talked about, and seeking and Panksepp have talked about. Then it might be just a matter of energy strength. This is kind of the resource capacity thing. And then the last thing they say is cognitive schemes, that might be another way of how motivation is shaping information, input, or interpretation. The question is where's the energy coming from? There's the idea that you're being energized by these drives. This is the older notion of biology, that drives push, and then the world comes, and then they shape the drives, and and then there's a top-down kind of cognitive thing that's really coming at us now in the last, whatever part of this decade, is that this is the stuff that it's easier for us to talk about this stuff in some way, because talking about neuromodulation, about cholinergic things, that's not a discursive language, first of all. That's talking about mechanics. So there's something that we're not getting there. And then how do you talk about that in terms of, like you're saying, these associations or these epigenetic factors? How do you talk about, well, this cholinergic system over here was developed in regards to these experiences. There's some language missing, I guess, is what I'm saying. Yeah. That's why we're having such issue with evolution of development, and there's a way of talking about it in terms of the genome and the MR, and, these kind of cellular factors. But it's harder to get the psychological language, the special science, psychology. How do you get that language to map onto that language? And it might be that you have to lean towards the cognitive, like he's doing, or there might be some more of a behaviorist language that we can find.
We should lean towards the biology.
We should definitely. We should.
No, that's a great way to put it. And yeah, I was thinking about this in slightly different terms, but you're right. Like, there is this old language of drives, which has never really gone away. Whether it's like a hydraulic, Freudian view, or whether it's like, a Desmond Morris kind of, there's a kind of instinctual aggression or whatever. And no doubt a lot of this is true, but you're right. It has a very hard time meeting this other language which we have, which is so content specific. So I've been interested myself in this thing I'm calling the content problem, which is, how is it that we put together something that seems so animalistic, like lust, or even things like play, like Panksepp's notion of play or care. How is it that these things have their actual intentional content? Because a drive is just sort of a push, it's just pushing you out towards something. But the human mind, and I suspect most mammal minds, have very specific content to the things they're pushed and pulled towards. And you can try to solve this problem easily by just going, it's in the genes. Everybody's afraid of spiders because spiders are somehow in your brain. Or snakes, same thing. Phobias, it's all just in the genes. Well, really, that's way more complicated than I think we're admitting, because it's hard to see how actual conceptual content, like the shape of an animal, like a spider, would be in any way engraved in how the brain gets actually built. Systems make sense because genetics makes systems all the time, but the actual content of your ideas, that's something very different. And so like you were saying, the solution has to be, I think for much of this stuff, will have to be developmental. But that's the story that, we're just starting to tell. We weren't even interested in developmental approaches to the mind until recently, because behaviorism dropped it out, then the cognitive revolution dropped it out. Now we have to sort of explain, interestingly enough, I think the reason why it's coming back is all the AI people are trying to figure out, like, how do you actually build up an intelligence system from the ground up? So suddenly they have to think about learning and developmental processes. But I think what they're doing is not looking at human development or animal development of mind. They're looking at how can we stack enough, algorithms together such that, these neural nets will basically be able to process what's happening. That's machine learning, but I don't think that's not creature learning. That's not biological learning.
I think that's a really good way to put it. And I guess the way I've heard people try to cash it out is to say, instead of saying snake, or let's just use a snake example, or spider, they say slithery things.
Yeah.
Or small slithery. Or then they're trying to take it out of the conceptual language, and they're trying to put it in a descriptive, perceptual language.
Yeah.
And that's really the extent of most of this work. And I guess it's a step in the right direction, but it doesn't seem like it's not cashing it out, is what I'm saying. It's doing something, but it's not the nuts and bolts, and it might not be specific enough. It might be kind of a hand wave.
Yeah. That's when I not that long ago I was telling you about this. I had the good fortune to sort of pick Steven Pinker's brain at a dinner, and I was asking him, I was sort of challenging him about the modularity in general, and he just sort of bringing up issues about, some of these processes of the mind seem to be much more flexible and penetrable by other systems, and he did finally say, well, we oftentimes talk about it like it's a Swiss Army knife, but really it's more like, the example he gave was like, it's like tissues in the skin, where things are much more complexly interwoven and interpenetrated. And then he did sort of wave his hand like, that's not really very interesting. And And maybe his idea is, well, somebody will deliver on that promissory note down the road. But I guess at the level that he's interested in, he doesn't have to solve that problem because he's just talking about, human psychology at a certain level, I suppose.
Yeah. Well, looking at this thing, yeah.
Go ahead.
I'm just looking at this thing. I mean, thinking, is this now it? Are people doing the work that we've been talking about and formulating for many years? Because the interesting thing about this is it's taking the cognitive neuroscience and it's taking the beginning of the affective wave, and it's giving it more neuroscience. Like, are these the nuts and bolts? Because one of the issues about all these things, of course, is that we've been doing conceptual engineering and neuroanatomical stuff at the same time, but we haven't been joining them. So sometimes people doing neuroscience with a bunch of bizarre interpretational ontologies, and that hasn't been serving us well. And the idea is, are we finished our conceptual processing yet, conceptual engineering, to have the right kind of neuroscience, the kind of neuroscience that is telling us about nature, not about some ideological version of how the mind might be working? I'm not convinced that we're done with the conceptual engineering.
Good, and I agree with you, and I see his frustration in this book, The Cognitive Emotional Brain, because he's trying to say, even though he's critiquing a view that I am attracted to, the dual processing view, he's saying we need to think not so much about function and structure as networks that overlap with each other. And then he uses the language that came out of that work by Varela and Thompson on emergence. And he's saying, look, the brain is an emergent system, and it doesn't just it's not a bunch of machinery that just flips a switch and then something happens down here because of its connections. Basically, he seems to be suggesting that this kind of interpenetration of systems creates the whole phenomena that we sort of clumsily call emotion, or the whole phenomena that we clumsily call cognition. And that instead, he says, instead of parts that are like suppressing each other, he says they are like a continuum. Now here, I don't quite like this metaphor, but you see what he's up to is what you were just describing. He's trying to say we need better conceptual approaches to the mind than what we've got, or ways to thread these things together. One thing I wanted to talk about is maybe this is sort of the philosopher in me saw something interesting here, which was if we return for a moment to the amygdala, which is simultaneously, reading or involved in sort of what is it perceptions, but also what's to be done. I couldn't help but think about the sort of fact-value split in philosophy, the sort of is-ought split. And, just to sort of get people up to speed, there's an old problem in philosophy that people date back to David Hume, and they say Hume noticed that you can't go from a pure description of the world, of how the way things are, to an evaluative or normative claim, which is the way you think things should be. So he says it's very hard to move from an is to an ought. And he thought this was, and many philosophers subsequently have thought, though, this is problematic for trying to understand morality and ethics, because the way, I don't think Hume was really as bothered by this as people make him out to be. He said you just need bridging arguments to go from the is to an ought. That's what he actually says. But a lot of people have said, oh, well, you see, there's a world of fact of what is the case, and science tells us about that world. But then there's a world of how things should be, which is the realm of philosophers and theologians and so forth. And in fact, Stephen Jay Gould famously argued, that there's he called this the non-overlapping magisteria, which means there's one area or magisteria of the sciences, which is empirical, and then the other domain is one of value or ethics and meaning. And he says that they really shouldn't be even like playing in each other's, sandbox, so to speak. They should be totally separate. Now, as a philosopher, the is-ought distinction, the fact-value distinction, has always seemed to me to be overblown. The worry is that you can't just study the nature of molecules and biology and then figure out, that you want to have a world of democracy and human rights and all of that stuff. It doesn't sort of flow easily. But my objection to this distinction has always been, well, where else is this stuff coming from then? Where else are values, in a sense, emerging from? Now, religious people will say, well, God gives us these things, our sense of values and morality. But I think I don't find this compelling, and it seems like Deus ex machina, really. But what I liked about Pessoa's article is he's saying, look, there are features of the brain that are actually simultaneously coding for what is the case and also what ought to be the case. Now, the amygdala is not moral. It's not a moral organ, but it does tilt you like, I'm attracted to this thing, or I'm going to stay away from this thing, whatever it is. And in a sense, like if you're just having this biological response to your environment, attraction, repulsion, this thing is very attractive, I'm going to go towards it and increase pleasure, then in some sense your brain is a values generator. It's not just cognitively framing the world or describing the world. It is giving you a normative system right from the get-go. And my suspicion is like once you've got that in place, then things like culture, language, cognition can scale it up to the levels that we recognize as, well, you shouldn't hurt people. You shouldn't injure innocent people. Well, why is that? Well, because in a sense, the biology of our bodies has already informed us that pain is bad. Pain should be avoided. And so things like normative systems seem to me to be ways of managing what the brain and body is already doing at this low level. Does this make sense?
A little bit. A lot, but there are some things that are a little bit complicated. Like it sounds like you're kind of saying like Spinoza, that there's pain, pleasure, and desire. Those are the basic ones. And then the way the system does that is it evaluates things with these drives or something. But then you're starting to get into the real values, which I think they would call cognitive schemes. And it looks like those cognitive schemes, in my opinion, are cultural and ideological, or ideology is part of culture. And then those things are framing the energies as they go up.
No doubt that's true. I agree with you. That's what I mean by there's a kind of scaling that culture does. But I think I've been looking at, just on the side, I've been looking at Adam Smith's Theory of Moral Sentiments, which is such a good book. It's phenomenal. So much fun. And in it, he's arguing that you first have feelings of sympathy, which are basically part of the natural palette of feelings, just like there's a selfish drive. Smith says, we, as like other animals, also have a kind of altruistic drive or sympathy to help others, but it's very rudimentary. And he says you can see evidence of it when the examples he gives are kind of fun. He says, have you ever been watching somebody on a tightrope walker, and you find yourself like watching the tightrope walker, but you're like squirming like in your seat? And he says also, if you were to see somebody about to be struck with a stick on one of their limbs, he says you would feel a great trepidation. You yourself would have a sympathetic feeling automatically, part of the automatic equipment. But then he says, basically most human beings and animals have this. But the next step is that you need to be able to adopt like a more sophisticated point of view swapping, like changing places with people, like there's a rudimentary feeling, but then also he says you have to use your imagination. It's kind of interesting because he has this pretty important role to play for the imagination. Imagination sees, oh, that person, what would it be like if I was that person? And then he says that's sort of the second step for real ethics. And then the third step is then you need further reflection and adjusting of those beliefs because you're using yourself as a template. And then oftentimes you're not a good template. You need further, consideration. So like he gives examples like if you see somebody crying and you find out they're crying about something you would just laugh about, you have to do additional work to feel like you want to help that person because your initial sort of imaginative swap with them doesn't give you much sympathy for them. So anyway, this is obviously a very different language from what we've been talking about, and yet it strikes me that what Pessoa and others are talking about is that really dense infusion of emotional forces and cognitive forces. And this is why I think Adam Smith is getting new attention as a moral psychologist. And I'm not interested so much in morality per se, except that it shows you how we do try to work up these evaluations of our experience into systems that then we have can further articulate with culture and things like art and religion and narratives and so forth. So that's a way in which cognition and emotion are very much intertwined. Not it's a different way than just looking at like fear or spiders or snakes. Looking at the moral life is also a merging of affective and cognitive states. Mm-hmm. Anyway, that's a lot, and it's a bit of a divergence from the piece, but I thought it was sort of on my mind, and it's a way of thinking about values and norms which are biologically based rather than sort of, it comes from heaven and just sort of drops into the system somehow. That just seems like unpalatable. Anyway, so what else here do you think is worth getting into in terms of this article? Oh, one more thing I wanted to ask you about.
Please.
Is one thing I really liked about it was he says, even if you see all this blood flow to these areas, how do you know what it means? Which I thought was a great point. He's like, it could mean that the amygdala is now working harder, but it could mean that there was a lack of activity and now blood is coming to solve an ineffective problem. You know what I mean? Like we don't know how to interpret it.
I'm so glad to see this kind of reflection in a neuroscience paper because usually it's usually not there.
Right.
The idea is that, look, we have these high bold levels. It must mean that this thing is active. And there was, in the beginning, for example, I will say Marcus Rakel wrote about this, saying, he was the initial theorist of this work, of cognitive neuroscience, saying, and Gazana got talked about a little bit too, that, we're not totally sure, but it could be this, it could be that. But then I think it just got thrown out after the first generation of graduate students learned these methods, and people liked printing these things, and all these journals came out, these neuroscience journals, and they wanted pictures of this stuff. And to me, it got totally thrown out about what does bold signal really mean. Because, it could mean it's working more, but it could mean it's just counteracting something else. Is it working more inhibiting? Is it working more excitatory? Those kind of questions you don't really...
Yeah, you never see that in any of these articles.
And you can't get that from the pure data. And having run some of these myself, there's so much interpretation going on after you get the initial things of how you set parameters and which subjects you use and stuff like that. There's a lot that goes into it. There's a lot of interpretation goes into it, and a lot of your own ideas have to shape the data.
I think you and I read this piece about gender processing of, was it fear, I think?
Yeah.
And it was looking at the amygdala and what are the differences, like what is it doing when women and men are processing fear. And I can't remember this exactly, but one of the things was related to this. Like they showed that, what was it again? Was it the amygdala was sort of activated longer in women than men?
I think so.
But what that means was very much up for grabs. Because one way to interpret it is, well, the females are in some sense unable to shut down the activation as quickly as men can. But the other interpretation struck me as entirely plausible and reasonable, which is that women often will enlist positive affect or positive emotions to then down tune the negative emotions. And those are two very different things, which might be showing up in terms of blood flow the same way. So what is it? Which one is it?
Yeah, or do you introspect? Did you ask them for introspection, or they don't need introspection because it's been conditioned in that's their thought process, so to speak. It shows that neuroscience in itself is not can never offer a complete description of thought processes. Neither can introspection and neither can behaviorism. But do they all meet somewhere? That's the hope of science, is that we can find these convergent methodologies. And I don't think we're there yet. But
yeah, I agree. That's sort of one of the lessons, I think, of this piece and in general. One thing I'd like to ask you about is if we could sort of go back for a moment to the prosopagnosia thing, because now let me sort of raise what I think are the problems with the Pessoa piece and argument is I don't think he's dispatched the dual process view or paradigm of a top brain and a bottom brain, or a system 1, system 2. I think he's raised important criticisms about it. But one, I would like to ask you to talk maybe a little bit more about the work you did, where it looks like the subject you were working with was able to somehow identify people he liked, even though he couldn't recognize their faces. And he was also able to recognize people he didn't like. Maybe you could just say a few words about the actual experiment.
Yeah, this is an experiment I ran, I think, in 2007 with patient MJH, 2008 or something like that. And it was I think it's in social cognition. I forgot which page, where it is. But in this experiment, I was trying to see, I gathered pictures of faces of people that patient MGH knew. And I asked his wife, are these people he likes or these people he doesn't like? And I collected all that information. Then I showed him these pictures and I gave him a 7-point scale. Do you like this or dislike it? And I asked him, and he said, well, I don't know. I'm not getting anything from this. It's just a blur to me. I said, well, please just answer it. So he answers all these. And then in the second phase of the experiment, I just gave him the actual names. Like, what do you think of Uncle Bob? What do you think of this person, that person? And then he rates them. Then I took them and I correlated them. I found it's over 70% correlation between the responses. And it was in both directions. He likes people and he dislikes people, and those were all correlating.
Well, that strikes me as like kind of evidence in a way for some kind of dual processing, that when he looks at the face of his wife, he just sees like mishmash and like nothing he can identify. Doesn't even know it's his wife. But there's what would it be? What's the system that's identifying her?
Well, that's what I get into in the discussion, is that is he getting some feeling, like how is he rating it? If he's telling me introspectively, I have no idea, then he has to answer it. He just answers. He feels he's answering randomly, but what is making him choose on this side of the scale, this side of the scale? Is it random? You test against. Is it random? We did some tests like that. And the idea is it the object that is generating a value in his mind, or is his affect is going along and he's it dips a little bit, it goes up a little bit. You see, is it because of the object, or is it because of some sort of mood? And I haven't found a way to disentangle those two things yet. I'm sure there is a way to do it experimentally, but that would be an important question. with cognition and emotion, because I'm kind of assuming that it's in the two system model that it's the affective thing down there that he's referring to answer it.
Yeah.
But of course, the answering process is it seems like a cognitive process. But if we look at this framework here, we could say that there is no cognitive and emotion, and they help each other out when they need to be helped out. Like if his cognition is kind of blank, he doesn't know who it is, that there is some other information down there that he can reach into. And he's doing that all the time because he's prosopagnosic all the time, and he always has these issues when trying to recognize people.
That is a really interesting experiment, because if it was like in real life, there must be other ways in which he's getting signals. You think right away of olfactory sensing. You smell people. You have touch, voice,
they have
and hearing.
Hats on.
Yeah.
Glasses.
So there's all kinds of ways in which the body could be reading. That's somebody I like. That's somebody I don't like. But in the experiment you did, all he's got is like a 2D visual representation. Yeah. And it really, like you said, is there something in the object, like, is there a general morphology of this face that he recognizes even though he doesn't know he's recognizing it? Mm-hmm. Or is it, like you said, something to do with there's an affective flow that's happening and somehow these shapes trigger a change in that affective?
Yeah, the interesting thing is that he has been prosopagnosic since the age of 6.
Oh.
Which would mean that all of these associations must be being learned in some sort of conditioning method, presumably. Yeah. So there must be these conditioned templates of these morphological forms.
Yeah.
Yeah, that is another element of the work that has been under theorized, I'd say.
Yeah, and that could be influencing his evaluation, his judgment, his deliberation, even though it's opaque to his conscious mind.
Yeah.
Yeah, that's fascinating. Okay, so related to this then is my other sort of major complaint about the work that Pessoa has done, which is that for me, it's not evolutionarily grounded. And that one of the advantages of a dual processing system, having an old brain and a new brain, is that it's so consilient and consistent with evolution, with how we think vertebrate and mammal and primate and eventually Homo sapien brains emerged. And it's pretty clear that at least some of the really unique cognitive and cultural elements are in more frontal areas of the brain and in more recent parts of the brain. So in that sense, I think he's just sort of slicing into the human mind now, in the 21st century and going like, what's going on here? Total mishmash of emotion and cognition. But if you look at that mind over evolutionary time, I do think there has to be nothing like sort of dumb layers, but there has to be sort of the accumulation onto older parts of the mind brain by these newer capacities, including the symbolic mind of Homo sapiens. So in that sense, I think he's missing something.
Yeah, and we've talked about this before, but there is some sort of embedding going on. These things are embedded, and the word we've used from that book is the kludge.
Oh, yeah, kludge.
Being that the brain evolved, it just built on top of it. So there's a bunch of redundant processes, and it's a big mess. It's not literally this triune layer thing.
Right.
And he does say that towards the end, something about, it's embedded, it's not separate. But you have to get into comparative neuroanatomy here. Right. You have to do ethology. You have to do animal ethology to get those other behaviors, and then those brain. They're starting to get brain scans, better brain scans of primates. That's happening very recently. I think that has to be done. The human mind is such a unique form. If you look around at every other animal, every other creature on Earth, it's not like that. But I guess that's what we're trying to explain as a human in some way. But we can't do it outside the context of the rest of nature. That's foolish.
That's right. I agree. I think that's a perfect note for us to end the conversation. We've been at it for an hour, and I think we covered some good ground. I think we both like this work a lot and recommend it, but we've got some objections and further, criticism. So maybe we'll come back to this kind of stuff. But for now, anyway, we're signing off.
Thank you.
Thanks, Rami.
Thank you, Steve.